Okay, here we are in part 2. You should have watched part 1 and done all the work up to this point. And we're going to go ahead and continue with our discussion of angular into linear quantities. You might notice a pattern. The angular velocity to linear velocity formula is almost identical to the angular displacement to linear displacement, and that is, it's just multiply the angular quantity by the radius and you'll get the linear quantity. So if you want to know the velocity of a point, the tangential, what is called the tangential velocity of a point at this point, you would just multiply its angular velocity by the radius. So key, you will see this term spoken or written. Tangential velocity, that's a key term right there. All right, so if a circle is rotating with an angular velocity of omega equals 3 pi over 2 radians per second, point A is on the circumference of the circle of radius, 3.5 meters. What is its tangential velocity? So we're going to very simply say I know V is omega times R, so 3 pi over 2, come on, times 3.5 meters equals, so 5.25 pi meters per second. Meters per second. All right. Answer a text here. Sorry. Okay, we're back. Haha. Okay. Go ahead and take a practice of this. So how long would it take a point on the circumference of a circle with a radius 5 meters to travel 10 meters if the circle is rotating at 5 pi over 6 radians per second? Go ahead and pause, then come back, and we will go ahead and get this done. All right, we're picking it back up. So, first of all, we need to know, so the displacement that we need to travel is 10 meters. We know that velocity is displacement over time, meaning displacement is velocity times time. That means that velocity equaling omega times r, 5 pi over 6 times a radius of 5 equaling 25 pi over 6 meters per second times, oh wait, no, we don't need that. We need the other way around. We need time is velocity, no, displacement over velocity. So we have 25 pi over 6 meters per second. That means we need, need more space here. The displacement is 10 meters over 25 pi over 6 meters per second, giving us, if you will pardon my calculatoring, 10 divided by 25 pi over 6. Cool. 0.763 seconds. Ish. And you may have guessed, very straightforward, angular acceleration to linear. Linear acceleration A is angular acceleration alpha times r. So the linear acceleration of any point on a circle is equal to its angular acceleration times the radius. All right. A wheel undergoes an angular acceleration of alpha equals 2 pi radians per second squared. The circle has a radius of 4 meters. What is the linear acceleration on the circumference of the circle? What is the linear acceleration? So it's really just as simple as you might think it is. A equals alpha times r. So 2 pi times 4 equals 8 pi meters per second squared. And time for you to practice. A wheel with a radius 0.5 meters starts at rest. It undergoes an angular acceleration of 3 radians per second squared. How long does it take a point to reach a linear velocity of 6 meters per second? So go ahead and figure that out, and we'll come back to it. Okay, I'm going to assume that you have solved the problem, and we're going to go ahead and look at what the solution is. So let's list what we know. We know that the radius is 0.5 meters, and the angular acceleration alpha is 3 radians per second squared. So that means that the linear acceleration is 3 times 0.5, giving us 1.5, sorry, not radians per second, meters per second squared. We start from rest, meaning our v0 is 0 meters per second. We want to know the velocity, which is 6 meters per second. We're asked to find the time. So if velocity is v0 plus at, velocity of 6 equals 0 plus 1.5 t. That goes away, divide by 1.5, and we get a time of 4 seconds. All right, the next thing we need to learn is called centripetal acceleration. Centripetal acceleration. This is slightly different than angular acceleration. It is a linear quantity, but it is specifically the acceleration towards the center of rotation that a particular point feels when it is angularly accelerating. And what it is the tangential linear velocity, okay, the tangential linear velocity, so Vt equals tangential velocity divided by the radius, okay? That's a formula that you should see on your formula sheet somewhere. Where is it? Yes. It is the 1, 2, 3, 4, 5, the sixth equation down. AC equals V squared over R. AC equals V squared over R. They dropped the little t, but you need to know that that's what it stands for. Okay, so an example of this would be a point on the circumference of a circle of radius 1.5 meters, has a tangential velocity of 1 meter per second. What is its centripetal acceleration? Very easy. AC equals V squared over R. So AC is 1 squared over 1.5, giving us, calculator, an angle centripetal acceleration of 0.67 meters per second squared. And that's in meters per second squared. It is a linear quantity. Okay, go ahead and practice this. A point on the circumference of a circle of a radius 1.5 meters experiences a centripetal acceleration of 4 meters per second squared. What is the tangential velocity? And then, conversely, what is the angular velocity? So go ahead and give this a pause, and we'll see if you can come up with the right answer. Okay, I'm going to assume that you have paused and come back to the video. We're going to solve it. So the centripetal acceleration, AC, is 4 meters per second squared. The radius is 1.5 meters. So if we use AC equals V squared over R, that means that V squared equals AC times R, and in our case that's 4 times 1.5, giving us 6, and that equals V squared, so the velocity itself is the square root of 6, which, calculator, is 2.45 meters per second. That's the first part. And then it's asking what is the angular velocity. We know that linear velocity, v is omega times r. So if we divide by r on both sides, we get omega, and that is 2.45 divided by the radius of 1.5, giving us an omega of 1.63 radians per second. Okay. I would like you to derive an expression for centripetal acceleration only in terms of omega and r. Only in terms of omega and r. So if you want to go ahead and try that, I will be quite happy. Okay, now that you've given it a shot, I would like to show you what I would do. So I would say, okay, I know that AC, centripetal acceleration, is v squared over r. I also know that v is omega times r. So if I substitute that in, I end up with AC equals omega r all squared over r, giving me omega squared r squared over r, or omega squared r. And there you go. Okay, now I'd like you to do the centripetal acceleration and tangential velocity worksheet. That is really all the work that I have for you for this week for the rotation unit. I honestly have no idea what day you'll get to this, to be perfectly honest. If it's Friday, great, shop week or finish it in class. If it's like Tuesday and you guys are absolutely crushing it, you guys can watch a couple of videos, Mythbusters, Kurzgesagt, CGP Grey, SciShow, Smarter Every Day. And if you really are like, yeah, we want to do some work, we want to get stuff done, email me at mchristiansen@baypath.net, and I can set up an extra lesson for you guys if you want to be educated in this time, okay? So, you're all great, be well, and I'll see you later.